In this video, I will talk about the call stack in the C++. So, firstly, let's understand what is a stack. Stack is a data structure which follows last in, first out mechanism. What does it mean? So, it means that uh, the element in this stack, it contains a set of elements. So the set of elements will be accessed with mechanism last in first out. So the element which has been added last will be accessed first, will be removed first. Okay, so it has three operations. It's push, it's adding the element to the stack. Pop, it's removing the element of the stack, and pick, which is getting access to the top element of the stack. And when you get access to the top element of the stack, you cannot get access to the uh, when there is a top element, we cannot get access to the next elements. This element will be accessed only if this element is popped, is removed from the stack. What is call stack? So, C++ program can contain several functions, and when you run the program, it will start from the main function. So, all other functions will be executed only if it invoke it, if it invoke it will be invoked, or if it will be called from the main function or from the function which is executing. So when program starts working in the memory area, so name it call stack. So for example, it's all of area is memory, and it's a call stack. It will be created the activation record for each function. Firstly, it will start from the main function. So main activation record from the main function. So in this case, it will just do line by line the main function, and for each like for each local variables, it will reserve the area in the memory and then create a variable here. When you assign something to this variable, it will write in the address this value. Here it is 5, so it's a 16th of 9. And when it calls other function, then in the call stack will be added the activation record for this function. So it's, for example, for the print factorial function here in the 17th element, and the control will be taken by this function. It will also work line by line if it has several lines. So, first, before the running this function, it will create each variable in the in the arguments list like this, and 5, for example. Here this n and this n is not the same, so here it can be like this, the expression, the number itself, and the n. So in any functions, it will require the expression, and it will not this take same address for each function. It will be created from scratch. Here it will be like this. For each argument, it will create the variable. This local variable, it will also be created. So, and then here it will write the here it will just calculate the expression if it is, or get the value of the n, and then adds it to the and gives it to the function. So function will get this variable, and then Assign it, so create the each variable in the arguments list and assign it to the value which you give in this in when you call this function. Here it will be assigned to the 5. Also, it can be so this n and this n is not the same, and the local variables of the main will not be accessed by the print factorial function, and the local variables of the print factorial will not be accessed by the main function. So control will be in the print factorial function. It will do line by line the code, and when it sees the other function like factorial, it will also give the control to this function, and C++ will add the activation record for the new function. Here it will be factorial function, and it will just give access to this factorial function like it's in another area of the code like this. It will also be 5. And when the factorial function reaches the result, when it reaches the return statement, so return statement will stop execution of the function and gives the result as here, and then the activation record of the main function will be removed with the variables. So variables will not be removed, but it takes some time, so you will need to delete it by yourself. But in some languages like C++, it works samely, but they will remove it by garbage collection. So in C++, garbage collection is not how to say, is not implemented. You should do it by hand. If you should be careful with the memory. And then when this function reaches the end of the this function or reaches the return statement, it will also be remove the activation record for this function, and the main function will take back the control. And then when main function reach the return 0 statement, it will just the activation record for the main function will be removed from the call stack, and then this program will exit execution. Okay, so as you see here, as you see here, we can so function can call themselves each other. So print factorial function can call factorial function. Factorial function can be called by the main function. Maybe print factorial function was called by the main function. So here also the factorial function can call themselves. It refers as recursion. So, for example, by the mass, we know that from the mass we know that factorial of n is the product of n and the factorial of n minus 1. But if we leave the code like this, then it will cause the stack overflow error exception. So what does it mean, stack overflow? It means that when factorial function for example n is 3, yes, it will just do like this. So for each call of the factorial function, it will just create like the different activation record for this factorial function in the call stack. Here it will be like n is 5, yes. Here it will be n is it will create the variable n, which will be 4. Here n minus 1 will give Yeah, let me just write it. It will infinitely create it, and then after some time the stack will be how to say, it will be filled, so the memory will be filled by the activation record of the factorial function, and then you will get a stack overflow error like this, like this, this, and like this. N will be here, N will be 4, 3, 2, 1, 0, and -1, -2, -3, and so on. So in one moment it will fill the memory and the program will crash. What to do to avoid this case? You can just add here the case, the base case. So the case when this program, this function, the recursive function should not how to say, should not call yourself themselves. So it will be like the case when n is less than 2. 2, we can just return by the math. We know that from the math we know that we can return here the 1. So in this case it will not reach this 0. It will do like this, and then when it reaches 1, it will just see this return statement, and then activation record will be removed, and so on. It will take control of this activation record, this function, and so on. It will stop working. It calls recursion. It's all about the call stack.